A namespace functions as a container for related objects in the .NET framework. A major benefit of namespaces is that they prevent name collisions, so that the framework can have multiple objects with the same name, but the compiler can unambiguously resolve references to the correct object at compilation. Another benefit is that once you learn the overall structure of the namespace hierarchy in the .NET framework, you'll have an easier time finding what you need, although Google and Bing are pretty useful too. Now there are several top-level namespaces from the BCL that you're likely to use often in your C# programs, some depending on the type of application that you're building. There are many more top-level namespaces, and most of them have several layers of hierarchical namespaces below them. There are a lot of features within the framework. The one namespace that you use in every application you write using .NET is System. And this includes all of the essential support that you need for your programming, including things like base types, strings, integers, datetimes, booleans, so on. It has a lot of math functions, garbage collection, which cleans up memory management, and more. Every .NET program you create is going to use this namespace. And then there's System.Data. And this provides classes for working with different kinds of data, including reading and writing data to and from SQL Server, OLEDB, and ODBC. System.Diagnostics provides classes that you need to diagnose your applications, including doing things like event logging, performance counters, tracing, and process management. If you write applications for multiple languages, you'll be interested in the System.Globalization namespace. This includes fundamental support for globalization, and it's used throughout the rest of the .NET framework. Nice thing about the framework is that it supports globalizing applications, including different languages. System.io has a lot of classes that you'll use for fundamental stream support to target the Windows file system, including classes that can manipulate files and directories. System.Text, as the name implies, includes support for text encodings and the string builder class that you can use to very efficiently build different strings. System.Text.RegularExpressions is within the System.Text namespace, so you can start to see the hierarchical nature of the namespaces. And this includes very strong support for regular expressions that you can use for robust parsing and matching of string data. System.Web, if you're going to write web application, provides design time and runtime support for creating and displaying ASP.NET web applications, including MVC, or support for MVC. And then on the desktop, you have System.Windows.Forms that provides controls, designers, and runtime support for building Windows-based applications. And then the last common one that you'll use is System.XML. And this provides support for reading and writing XML content. And again, this is just a small example, a small subset of all of the top-level namespaces that are available that you can use within the .NET framework. The code you write in applications will be a mix of code that's specific to Visual C# and code that uses the classes in the .NET framework. And this code here, the split cost method, is a good example of that. So what the code does is it takes total amount, and it's going to split that up for two different people who are sharing a check, essentially. That's kind of the scenario. Obviously a very simple kind of example. And so I have a decimal total amount, so that's the amount of the check, and then I have the total dollars and total cents, and we're going to split that up. And so total dollars, I use the truncate total amount, that removes the decimal portion. And then total cents is going to be the difference between the total amount that has 0.61 decimal minus total dollars, which is now rounded down. So that's going to be the cents amount. And then we output it. Restaurant bill is such and such, and you pay this, and I'll pay the other, total dollars and total cents. Okay, so very simple kind of an application. But behind the scenes, what's going on is that the system namespace of the .NET framework defines both the decimal structure and the console class. So right there we're using the system namespace. Now, the syntax for declaring these variables and initializing them are specific to C#. But then, using decimal.truncate Truncate is a method that is implemented by the .NET framework. Console.WriteLine is the same thing. So these are features that are provided to my program by the .NET framework. So they're not specific language features that are built into the language itself. And then the formatting here, where I'm converting this value to a currency, is also part of the .NET framework. So the important message here is that the language features are largely provided by C#, but much of the support infrastructure of your application is provided by the .NET framework. In fact, many language structures are actually supported at compile time. If you look at the compile code, they're actually calling some sort of method in the .NET framework. So what I'm going to do now is start to show some of the classes that are available in the .NET framework. So this is going to be far from a comprehensive examination of all the classes. This course would be years long if I tried to do that. But I want you to get a feel for what's available so that you kind of know how things work, as well as when you need a particular piece of functionality that you suspect is common enough for Microsoft to include it, so that you have some idea of how to go about finding that functionality. All right, so the first thing I want to talk about is generating random numbers. Very common need within an application. So the way you do that for what are really called pseudo-random numbers is use the random class. So right there you get a feel for, if you're looking for random numbers, you search for random, you'd find what you're needing, because things for the most part are pretty sensibly named. Now, the way this works is that you new up an instance of this random class. And the way that the random class works is that the random numbers that it generates start with a seed value. Now, you can specify the seed value or use the default seed value, which is based on the system clock. And then to create random numbers, you first need to create this instance of the random class that I do here. So I'm going to be working with this random number variable. Now, what's a class? Well, real briefly, you can think of a class as a blueprint for an object. It's the definition, it's the code that's saved within the framework library that defines the behavior of an object. And then, as I've done here at runtime, you instantiate, or new up, coming from the new keyword, you new up an object that is the actual in-memory instance of that class that has the behaviors. It has memory locations where you can store data. It has code behind it that you can execute to take advantage of whatever behaviors the creator defined for it. Okay, and you can have multiple instances of the class in memory based on the same blueprint, essentially. Okay, then when you're ready to grab random numbers, you can just use the next method, and that will generate the next random number in the sequence. Now you can also pass a number to the next method. This parameter specifies that the next generated random number should be less than that number. So now I want a number less than 100. And if I pass two numbers, that specifies that the next generated random number should be between the first and the second number. Okay, so let me run the application. Press F5. And I'll first look at the split costs, and there you can see the restaurant bill is $0. Okay, so we have a problem in our code. Let's see. Okay, let's see what's going on here. So we have total amount, truncate total amount, and display it. Okay, nothing obvious is wrong, so I'm going to set a breakpoint here, and I'll start executing again, and press A for split costs. Okay, so here I can examine my variables. I have 4561. That all looks fine. I'll execute the next statement. Total dollars is 45. And next statement, total cents, is 61. Okay, so my values are correct. So something must be wrong here, and I see exactly what it is. Okay. So what happened here is that I took some earlier code and converted it from the old style of formatting a string and used the new style of string interpolation. But what I did is I put the $sign here, but I didn't put the variable into the value. So I'll go ahead and correct that. I'll put in total amount. Nice, I get IntelliSense. And then I need to get rid of this. Do the same thing here. Oops, actually the first one is here. So total dollars and total cents. And then get rid of these. That's a little bit something that's mildly surprising about string interpolation is that it has this nice new format, but it does allow you to still pass parameters. So I didn't get a compile time message nor a runtime error, that I still had those parameters outside of the string. And so, but I got erroneous results. Okay, so let's test this again. Press F5, which automatically saves my changes, and I'll get rid of the breakpoint. So we run the code straight through, and I'll press A, and there we go, we get the results that I expected. Okay, so a little live demo of debugging and a method. Okay, so now let's look at the generate random numbers. Press B, and you can see that here's a random number. Remember, I selected, or I wanted 3 just totally random numbers. And then I wanted a random number that was less than 100. And then I wanted a random number that was between 500 and 750. So that's how that works. That's how easy it is to generate random numbers using C#, but really calling on the features of the .NET framework in order to access all that it has available to you. Okay, so before I leave the topic of random numbers, there's one thing I need to mention and make very clear. This version of a random number generator in the .NET framework is fine for most business needs for reasonably random numbers, and it's very easy to use. Again, you just new it up and then you call the next method, and if you want to pass parameters to it, fine, and you have your random numbers. But it's important to understand that the numbers are not cryptographically random. Cryptographically random numbers is a much higher standard for randomness that's demanded by security features in your programs. So if you're writing security-related code, be sure to look into the random number generators in the system.security.cryptography namespace. Those generators are a bit harder to use. They require more code, but are far more secure. They're guaranteed by Microsoft to be cryptographically random. Another handy class in the .NET framework is the system.environment class. This provides a bunch of properties to view information about the computer and the environment in which it's running. And it includes things like machine name, which returns the name of the computer. Username returns the name of the user. Now, this does depend a little bit on how the user is authenticated against Windows. It may not always be available under some authentication schemes, so just be aware of that. It also returns the OS version, which is the version of the operating system, both the name and the version. Current directory returns the directory in which the program is running. And then version returns the version of the common language runtime that you're currently executing under. This has some interesting implications. You could include the version number of the CLR in your code, test for it, and then execute different code based on what version you're currently running under. That's a pretty esoteric technique. I'm not sure that I've ever done anything like that in any of my applications, but it does show just how flexible it is to use the .NET framework. Here's some code that uses the system.environment object. So I just defined a method, and I have various write lines, and all I'm doing here is just reading these different properties, the values of these properties, from the environment object. So to get the machine name, I just have environment.machinename, username, OS version, current directory, and version. So very simple to read that information. I can display it to the user. I can use it in some sort of if statement to run code if the current version of the CLR is something, or if the username is Don, I can format the hard drive, whatever is appropriate for the code. So like I said, very easy to use. And then I have some additional code down here that exercises the get folder path method of the environment object. So what this code does is it news up a file info in order to get a reference to a specific path, in this case a specific file. So this is a file that exists on my hard drive. As the comment here notes, it has to already exist. And then what I'm going to do is I'm going to use the method of the file info object in order to copy this to a specific location. So in this case, I'm going to get the folder path for the desktop. So this is using the get folder path method of the environment object in order to get the path to my desktop. So the idea here is that different versions of Windows put the desktop folder in different locations. Nice thing about it, the environment special folder enumeration is that it will give me what the path is on this particular machine running this particular version of Windows, which happens to be Windows 8.1. Haven't quite made the jump to Windows 10 yet. All right, and then I concatenate on the name of the file there. So now that is the destination. This whole resulting string is going to be the destination for the file that I'm going to copy it to. And then I just print out a little note that telling the user to check that text.txt has been copied to the desktop. Okay, so I'll go ahead and run this, press F5, and press C, and there you have, machine name is this big wild name, username is Don Kiley, OS version is Windows NT 6.2, which equates to Windows 8.1 actually, using Microsoft's rather creative versioning. Current directory where this application is running is that location right there, and the CLR version that I'm currently executing under is 4.0.30319.42000. Okay, and then it prompts the user, asks if the file has been copied to the desktop. Let's minimize there, and there's the file right there. So yes, it has been copied to the desktop and the code works. Okay, so I'm going to end execution here and come back to my program because there's something I need to talk about. These two different chunks of code, they operate a little bit differently, and that gives you some insight into sort of an interesting feature of classes. Okay, and in fact I'm going to come back up here to the random number generator. That's a little bit clearer an example. So here I newed up a random object, a random class. So I had to do that before I had access to the next method. If I had not done that, this variable, first of all, would not have a reference. It would be null, and nulls don't have a next method. But more precisely, I can't execute next directly on the random class. But down here, in order to access the properties of environment, as well as to use the getFolderPath method, I didn't have to new up an environment object. You don't see any code like this for the environment object. The reason for this is that the next method is an instance method of the random class. I need an instance of the object in memory in order to call that method. But getFolderPath is a static method of the environment object. Okay, so those are the two different terms. Now, an instance method is a method or property that requires creating an instance of the class it belongs to before using it. That's the thing that determines it. Next method is an example of an instance member. A shared method, which is actually called a static keyword in C#, but shared is the more common term. And somewhat ironically, that's the keyword in Visual Basic that language uses for this, but it's called static in C#. So a static method is a method or a static method or property. Those are members that you can use without first creating an instance of the class. And so because getFolderPath is a static method of environment, that's why I didn't need to new up an environment variable. Same thing with special folder. Special folder is what's called an enumeration, particular kind of an object that you can include within a class. And I didn't have to have an instance of the environment object either. Okay, now I can create an instance of the environment class, and then I have it in memory, but I don't need to for these particular objects, or these particular members of those objects. And then in fact, WriteLine is yet another instance of a shared member, static member. So this means that the code throughout this course, throughout all of the code where I've used console.WriteLine, I don't need to first create an instance of the console object in memory in order to use its members. Now, it's very possible and very common to design a class with both instance and shared methods. In that case, you need to create an instance of the object before using any of the instance methods. But you don't need to if you're only going to be using the static methods and properties. Okay, so we'll see more instances of the difference between instance and static members throughout this course. So keep your eyes peeled and you'll start to notice when I don't need to new up an object and when I do.